Okay, so in this video I am going to continue the concepts of transportation problem. In part 1 already have discussed how to solve the transportation problem of phase 1, initial basic feasible solution, by applying different approach: northwest corner cell method, least cost cell method, and Vogel's approximation method. And we compared and we find Vogel's approximation method is one of the best method to find the initial basic feasible solution. Sometimes Vogel's approximation method gives optimal solutions. So if there is no conditions over the questions in exams to find the optimal solutions by applying either of the methods, so it's better to go for either of these two methods to find the optimal solution, means either a stepping stone method or UV method. But for initial basic feasible solution, it's better to go for the Vogel's approximation method. So in Vogel's approximation method, you will get the solutions in very fast, because after just getting the conditions is going to satisfied. So what is the conditions, on which basis just we need to proceed for the steps to get the optimal solution? Now we'll see here in these steps. So now I'm going to take one examples of initial basic feasible solution which already have solved in part 1. So you can see this Vogel's approximation method to find the initial basic feasible solution. So applying the initial basic Vogel's approximation method, we got the initial basic feasible solution 1020. So this is the cost of transportation through. So now going to apply the stepping stone method, and we'll see if their cost is going to reduce or this cost itself is going to be considered as a optimal result. So just we'll check by applying the stepping stone method. So now I'm going to apply the stepping stone method to see its optimal solution. So stepping stone method, what stepping stone method says? Very simple. A stepping stone method says to check for all unallocated cell, because allocated cell already we got through the Vogel's approximation method. So these cells already have got allocated. Cell 2 1 2 2, cell 2 2, second row, first row, second column. So cell 1 2 1 3 2 1 2 3 2 2 and 3 2 and 3 4. So these all cells are already have allocated cell, and rest of cells are unallocated cell. So we will move to check is there unallocated cell is going to give some result there. We can reduce the cost of the transportation. So we will check what is the procedure to check. That is very simple. Just we need to put a dot here in the unallocated cell, and we try to move from allocated cell either vertical or horizontal. Just remember, we cannot move in some diagonal or we cannot move in slanting way. We have to move in either vertical or horizontal with allocated cell. So first I am going to mark this first cell as this is the unallocated cell. So now I am going to start from here, and now we'll try to form a cycle by considering the allocated cell. So now we can move from here to this 25. This is the allocated cell. This 5. This is the allocated cell. This is the 45. This is the allocated cell. And now here. So these are the 3 allocated cell, and we started from the unallocated cell. Now here we'll check. If here I'm going to check the cost if going to increase, it means we are not going to consider this particular cell to make these cells as allocated cell. So wherever we find the negative sign in the sense, if we are going to consider +1, so this +1 is going to increase here the quantities, because 25 is already here, so +10 35. If you are going to add 1, it will give you the 36. To maintain this 36, to reduce this 36 to 35, means 35 is already have given at the source end, so you need to subtract 1. But if you are going to subtract this one, this value will get reduced, so you need to add +1 here. So 5 + 1 6, it will maintain this 30. Then again you need to give negative to maintain these quantities. So this is the condition. If you are going to give a positive here, then you need to give negative here. In this way you need to maintain the supply and demand conditions. So okay, so this is the condition. Now we are going to set first. Suppose I have given +1 -1 +1 -1. So this is the way just we write. This is just for the understanding. I have written here with the subtraction. So here the condition here, just to write positive, plus minus plus minus, alternate. If you are going to put here plus, then next minus, then next plus, then next minus, then only you can maintain the supply and demand condition. Okay, so now if you are going to put here, where we are which cell we are going to consider? Now we are going to consider unallocated cell 1 1, this cell. So we have considered this cell 1 1, first row, first column. So in this cell we can say, if we are going to see the cost here, that is 8 with the positive sign. Here cost is 10 with negative sign. Then again cost is 13 with positive sign, and negative sign with cost is 19. So just we need to check, is there any cost variation? If it is going to give a more cost, then there is no need to move from this cell to another cell. It means the cell whatever have allocated by the Vogel's approximation, we will consider that is the suitable to get the optimal solution. So how these cells are means is going to change or not, we'll see one by one. If this result is positive, it means if we will move from this another cell to this result, means the result will increase. So we are not going to increase the cost, we are going to minimize the cost of transportation. So if because concept here to minimize the transportation cost. To minimize means just we need to check either this is positive or negative. If this is positive, it means we are not going to consider to change the cell. So 8 plus 13, 21, 10 plus 9, 19. It means result is positive. So we are not going to change this cell. Now here, means this cell is not suitable to move from this other cell to this cell. So now this cell is not suitable now. Okay, then we'll consider another cell. We'll consider another cell. Okay, so next unallocated cell, we can say this cell is unallocated cell. So if we are going to consider this unallocated cell as a cell to check either this cell is suitable to move or not. So same procedure, we need to move either vertical or horizontal to allocated cell. Then this is the allocated cell. Then we can move to this allocated cell. Then we come back to this one. So now in this form we can form a cycle. So positive, negative, positive, negative. So positive means we need to check where we are going to check first row, fourth column. So we are going to check as first row, fourth column, 1 4. Here cost is 9. So 9 minus 5 plus 9 minus 6. Just check either positive or negative. So 9 and 18, it is also going to give positive. So it means this cell is also not suitable to move. Means here whatever the cells have got selected by applying the Vogel's approximation up to this cell, these cells are suitable. So now we will check all the rest of cells, which cells are going to find suitable. If none of the cells is going to find suitable, it means this result itself is a optimized result. It means Vogel's approximation method have already given the optimized result. So now if we are going to consider this cell, it means we need to move for some allocated cell. So which cell is allocated? This one is allocated, this one is allocated, this one is allocated, this one is allocated. Now it's going to form a cycle. If we are going to form plus, minus, plus, minus. So in this way we can check which cell we are going to check. Second row, second column, second row, second column. This is the unallocated cell. So plus 12 minus 13 plus 10 minus 6. So 13, 12 plus 10, 22 and 13 plus 6, 19. So it means positive. No need to go for this particular cell. It means I think we have to check one by one all the cells. This one is unallocated cell. So we need to move to this cell and check with allocated cell. So where to move to get the allocated cell? Because if you are going to move here, then we need to move here, then we need to move here. In this way we can move. This one vertical, then horizontal, then vertical, then horizontal, then vertical, then come back. So now it's going to form a loop. So plus, minus, plus, minus, plus, minus. If you are going to give alternate sign, then only you can maintain the supply and demand condition. So now we are going to check here at which cell? Second row, fourth column. Second row, fourth column. So second row, fourth column. Now going to check here. So 7, cost is 7 minus 5 plus 9 minus 6 plus 10 minus 13 minus 13. So just need to check this one. 6 here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 7 plus 10, 17. 17 plus 9, 26. 26. And this one, positive. So result here also positive. So we cannot move to this particular cell. Okay. Now, because Vogel's approximation is one of the best methods generally we consider. So sometimes Vogel's approximation method itself give a optimal solution. So that's why we always say Vogel's approximation method is one of the best method. If you are going to consider this cell, so how can we move to check? Because this is unallocated cell. So we can move like this. From this cell to this cell, 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 then again this cell, then again this cell. Now going to form a closed loop. So plus, minus, plus, minus, plus, minus. 1, 2, 3, 4, 5, 6. So you start from here for third row, first column. Third row, first column. So here you can start 14 with positive, minus 9, plus 6, minus 10, plus 13, minus 9, then 14 I started. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So now you add 14 plus 6, 20. 20 plus 13, 33. And 10 plus 9, 13, and positive. So result is positive. So in this cell also we are not going to consider this cell, because here also we have got the result positive. So what is the condition here? Means all the cells are going to give the result positive. It means no, this one is unallocated cell. So here no need to check. So which third row, third column, third row, third column. So here just try to make a cycle. Yeah, we can move like this. This allocated, this allocated, this allocated, this. So this is going to form a cycle. So plus, minus, plus, minus. Now check. 9 minus 16 plus minus, which one? Oh sorry, we started from here. This cell. 16 positive, minus 10 plus 6 minus 9, 4. 1, 2, 3, 4. So now 16 plus 6 and 10 plus 9, 26 and 19. It means here also positive. So none of the unallocated cell is going to be ready to allocate the values. It means whatever the result have got by applying this Vogel's approximation method. So Vogel's approximation method itself have given an optimal solution. So we can say optimal solution, whatever we have got by applying the Vogel's approximation method, that is 1020, this itself is the optimal solution. So Vogel's approximation method is one of the best method we apply to solve the initial basic feasible solution, and sometimes this method itself give a optimal solution. And now we already have seen, because now we are not going to change the positions of allocated cell to allocate the another unallocated cell. So we are not going to allocate another cell. Whatever the cells have allocated by the Vogel's approximation method, this itself is going to give you the optimal solution. So now the optimal solutions here we can see 1020, 1020, that is the optimal transport cost of the transportation to transport the goods from the some set of the supply points to some set of the destination points, supply to demand. So this is the one of the approach we may apply, that is the stepping stone method, to find the optimal solution. So these two solutions is going to match Vogel's approximation and this stepping stone method. But it is not always, you cannot say it's always. Means Vogel's approximation method means you cannot say it will give the optimal solution all the time. In this time we have got the same result. So optimal solutions have given by the Vogel's approximation method, but we cannot say this is always. Okay, just remember. So Vogel's approximation method is just we use to find the initial basic feasible solution. So whatever result we got by Vogel's approximation method, we cannot say directly it's optimal solution. We need to go for the a step 2 method, either a stepping stone method or UV method, to clarify either this solution is optimal or not. If it is not optimal, then there is an approach we will proceed to get the optimal solution. So in next video I will take, because these problems, this stepping stone method have applied over the Vogel's approximation method. I will take the same question and it will give the initial basic feasible solutions by applying least cost method, either least cost method or northwest corner cell method, because in least cost method or northwest corner cell method the result is different. It means this is the optimal solution. So least cost cell method, that is not an optimal solution. It means there needs some changes. So cell will get change. Some unallocated cell will become the allocated cell, and some allocated cell will become unallocated cell, and we'll see that cells is going to give you the optimal solution. So in next video I will proceed the same stepping stone method with least cost cell method. So okay, I think you have got the concept, and it's very simple, very easy. Just you need to practice some set of the questions, then you will be confident, and you may try some set of the question for the practice point of view. I'm saying, because practice is very important. If you are not going to give the practice, then you will forget the method. Suppose at some steps you forget the approach, how to proceed, then at the same time you need to stop and you will not get the final result. If you are not going to get the final result, it means there is no step marking, because here you need to compare against the Vogel's approximation method is going to give the optimal solutions or not. So here we cannot get, there is a step marking. So you need to remember all the steps and you need to go up to the end of the solution. So I hope you have got the concept and you will practice over some set of the questions. Okay, all the best. Thank you.